Hello everyone, Gaza Motkarsh, and I welcome you all to this session on data handling with pandas. So guys, let's have a look at the agenda for this session. The agenda for this session includes understanding series and data frame. Then we'll move on to the understanding different properties of series and data frame. We'll be utilizing different data frame operations, and we'll look at the different data frame functions as well. So prior to this session, guys, we have already covered data types, operators, variables, functions, modular scripts, along with list, tuple, set, dictionary, and their properties, their functions. And we have also discussed, let's say, NumPy arrays and list. We have also discussed indexing and slicing in NumPy, and followed by array operations, including matrix operations as well. So guys, let's switch to the Jupyter screen. So guys, now we are in the Jupyter screen. So let's understand what series and data frame is all about, right? So Python provides us with a library called pandas, and essentially what we are using pandas for, will be using pandas for data cleaning and transformation. We'll be utilizing it, let's say, for statistical modeling and analysis purpose as well. We can also use it for visualization, and it is the most commonly used library when it comes to machine learning data pre-processing and cleansing. Alright, and using pandas, we can also perform SQL-like operations such as group by, joins, and even filter, sorting. All these operations can be performed even using pandas. So guys, there are two data types that pandas has to offer, right? So these are the pandas applications. So pandas provides us with two data types, right? Two data types. What are these data types? Okay, let me mention the applications on the top. All right, that would make more sense. Now, pandas provides two different data types, namely series and data frame. So let's understand them one by one. So when we talk about series, right? So series is a one-dimensional labeled array, all right, that is capable of holding any data type. Basically, single-dimensional column हमारे पास है, that is what we refer to as series. So it is capable of holding any data type, be it integers, be it strings, be it float, be it a Python object, right? Now, every series would be indexed, and the indexed by default would be zero-based index, as in 0, 1, 2, 3, and so on. So it has two main components. किसी भी अगर हम series की बात करें, so it essentially has two main components, the values and the index. So values, that is the data that we have passed in the series, and then we have the index. So index represents the label for each of the data points, right? Now, a series can have more than one index as well, which is what we refer to as multi-index. So a single column structure that we can create in pandas is referred to as a series, whereas when we talk about data frame, so data frame is a two-dimensional labeled data structure with columns of potentially different types. For example, we do have an employee data set, right? So employee data set would have columns like employee ID, employee name, employee age, employee salary, employee joining date, employee profile, employee skill set, employee experience, let's say their address, their email address, all right, and so on. So each of these columns would have its their own distinctive data type. So data frame is a two-dimensional labeled data structure consisting of rows and columns. So if we were to represent tabular data in Python, so the data type that we are essentially looking forward to is referred to as pandas. And the structure that we are referring to is the data frame. So think of it as a collection of series sharing the same index. So as discussed, series is a single column data. Now if we stack multiple indexes, multiple series in parallel, so that would end up generating a data frame. Now each column of the data frame would act as its own individual series, and let's say data frame, it has rows and columns, each with their own labels. So we can have indexes and even the column names, right? And it can have more than one index as well. So both series and data frame can have one index. Now there is one differentiating factor. A series can't consist of more than one column. All right. However, a data frame can have more than one. So series can't consist of more than one column. However, data frame can have exactly one column. Means the structure wise data frame can be similar to that of a series, but a series structure wise cannot be similar to that of a data frame except for this one particular exception. Alright, so guys, now we'll move on to creating series and data frame. So let's create them. So how do we import pandas? We import pandas like this. Alright, so over here I'm writing import pandas as PD. Next, to create a series, what can be done? Over here I'm writing series, and then over here I'll be writing pd.series. Suppose I want to create a series of maybe let's say IT companies, right? Let's say AI based IT companies. So over here I'll be writing, or let's write the frameworks, different chat GPT based platforms, right? So first is chat GPT, of course, then we have Gemini, then we have Grok, then we have Claude, then we do have, all right, so then we have DeepSeek, and we also have maybe Quen, all right, etc. So this is a series. How do we know this is a series? So if I write S1, see over here I did not mention the index, but clearly it displays the index and the data. So these are the indexes, these are the values. I can print them, I can check them. So over here I can write S1 dot index. So see, the index starts from 0, the end is 6, and the step size is +1. Now if I were to see the values, so over here I can mention the values as well. So these are the values, and values are stored in list. Even if I pass a tuple over here, so values would be stored in a list or 1D array format. See, still this is a series, and what am I getting over here? This is a 1D array. Now I can also display s1.shape. So what is the shape returning? It is returning 6 comma. 6 comma indicates how many elements are present. There are total of 6 elements that we have over here. Alright, so guys, this is how we are supposed to utilize the series. Next, we do have the option of changing the index. Alright, we can change the index, we can change the values as well. Suppose I'm not convinced with these indexes, maybe I want to pass indexes A, B, C, D, E. So how do I change the index? S1.index. I can simply assign the values A, B, alright, then C, D, E, and F. So there are six values in total, so I'm passing 6 indexes. Then I can print S1. So as you can observe, the indexes have been changed. Alright, so guys, this is essentially what the kind of operations that we can perform with series. Now we do have n number of functions. So when we'll be working with data frame, so we'll cover the different functions. So moving forward, let's proceed with the data frame. Now, when we are going to, let's say, create a data frame, so there are different options to create a data frame, right? So what are the methods? Methods to create data frame. So we can create using dictionary. We can create using, let's say, array. When I'm talking about array, I'm referring to NumPy array. All right, let's call this 2D NumPy array. Maybe list of list or tuple, and vice versa, tuple of list or tuple. So these are the 4 approaches, and maybe we can create it using series as well. Even this approach is perfectly valid. So guys, these are the different approaches of creating a data frame. Now first of all, we'll be looking at how to create data frame using dictionary. So if you observe over here I'm having a data is a dictionary. Let's check what is type of data. The type of data that we get to see over here is a dictionary, right? Where key is the name, these are the values. Over here I've passed 8 different values. Then these are the different ages, and these are the different cities to which let's assume these employees belong. Alright, now I need to convert this dictionary into data frame. So what is the step? So I can write df is equal to pd.dataframe. Df is usually the variable into which we store the data frame. You can choose to have a different name as well. So in the data frame over here, I'll be passing data. So how does the table structure is generated? Each of these values, which we have passed essentially as a list, will be utilized as a column name. All right, these values will be used as a column name, and the name that you see over here. Repeat. So each of the values that you see over here, this list, this is going to get populated as the column values, and the key of the dictionary will be used as the column name, right? The key of the dictionary will be used as the column name. So let me display this. So if you observe, name, age and city will be the column names, and each of these lists will be used as the column values. So guys, this is my data frame. This clearly looks like a tabular structure, right? We have name, age and city, and in total we have 8 rows ranging from 0 to 7. So this index is not referred to as a column. However, it can be converted to a column if need be. So we have 3 columns: name, age and city. Now let's understand different properties of the data frame. So these are a couple of basic properties. The first one being shape. Shape simply returns the number of rows and column in form of a tuple. Then we have D types. So D type returns the data type of the columns. Then we have columns. Column returns the different column names. And we have index that returns the index of the data frame. Then we have values. So values return the values in form of 2D numpy array equivalent to that of list of list. But it will essentially be 2D numpy array. So let's have a look at the all these properties one by one. So this is my data frame. Alright, now for this data frame over here, I'll be using df dot shape. So what is the shape? 8 comma 3. 8 comma 3 indicates what is the number of rows. Number of rows is 8. What is the number of columns? The number of columns that we have over here is 3. Then we have D types. So if you want to print D type, df dot D types. So what are we going to get over here? See, D types returns, what does it return? Data type for each columns. So name is object, age is integer, city is object. In pandas, the string based columns are referred to as object. Alright. So name is also an object, city is also an object. So this is the function D type. This is the property D types. Then we have columns, index and values. So let's print them. So df dot columns. Alright. Then see, these are the 3 columns that we have. Then over here I'm going to write df dot index. So the index starts at 0, it stops at 8. So that is why we have values from ranging from 0 to 7. Alright, the values do range from 0 to 7 because the indexes start from 0 and the end value is 8. And what is the step size? The step size is +1. Then we have another property which is called values. So let me print the values. So value will display this entire data. It is going to display this data in form of 2D array. Alright, let's see this in action. So over here I'll be writing df dot values. So guys, if you observe this, this is nothing but a numpy array. How can we check? Type of df dot values. See, it returns a numpy array, right? So values is essentially a 2D numpy array. We can check the shape, it is going to be 2D. This is the type that we have checked. Then we can check df dot values dot shape because it is a 2D numpy array. So I can apply shape. Shape is 8 comma 3. Alright, 8 rows and 3 columns. So guys, I hope this structure is clear to everyone. Then let's have a look at some common very basic data frame functions. We can also use them with series as well. They are not just limited to data frame. I can apply them to series. First is head, then we have tail, then we have sample. Head simply returns top n rows of the data frame where n is supposed to be the function argument. If n is not mentioned, by default it will display top 5 rows. Likewise, we have tail. Tail returns the bottom n rows of the data frame, and if n is not mentioned, the default n value is 5. So it would return bottom 5 rows. The next function that we have over here is sample. Sample returns random n rows of the data frame, and if n is not mentioned, then the default n value is 1. So these are the functions that we use essentially to just have a look or the glimpse of the data that we are working with, right? So we have head, tail and sample. Let's see this. Over here I'll be writing df dot head. How many rows we have in total? We have a total of 8 rows, right? So if I do not pass any argument, what is the default n value? Default n value is 5. So what is it going to return? It is simply going to return top 5 rows. See, are we getting the top 5 rows? So guys, this is how we are supposed to use the head function. Then I can use df.tail. So if I pass, okay, I'll give you another example, df.head. If I pass 3, so what is it going to return? It will return the top 3 rows. Clearly we can see that we do get to see the top 3 rows. Next, over here if I pass df.tail, so if I don't pass any value over here, what is it going to return? Tail returns the bottom n rows of the data frame, and if n is not mentioned, it returns bottom 5 rows. So maybe over here I can mention bottom 5 rows, correct? So if you observe over here, by default it is returning the bottom 5. Bottom 5 is the last 5 rows. So the last index in the data frame was, I am assuming 7, right? So last 5 would be 3, 4, 5, 6, 7. So this is the data ranging from Ujjwal to Harshit. This is what we have obtained using the tail function. Next, if I use df.tail maybe 4, so it would return the bottom 4 rows. Likewise, if I pass 2, so simply bottom 2 rows, right? This is what it is returning. Then after df tail and let's say df tail 2, over here I'm going to pass df.sample. So in the default condition, just observe what is it returning. It returns random one row. It is simply going to return one row randomly. So if I run this, currently I'm getting row number 7. If I rerun this, see row number 0. If I rerun this, row number 6, rerun this, row number 4. So there is no order being followed. It is randomly generated, right? Completely randomly generated. Now I'll be using df.sample maybe 3. So 3 random rows. No order in particular. It can be any 3 rows. Please check. We are getting any 3 rows, right? So guys, I hope these functions head, tail and sample are clear to everyone. Now moving forward, let's understand how to read a single column as a series. So this was my data frame. Now if I'm supposed to read a single column as a series, so let's consider name. I want to display name as a series. So what is the option if I write df.name? This is currently a series. If I use single column of a data frame, it will be a series. Alright, but it is series only and only when I'm only using single square brackets over here. Let me check the type. Alright, over here I'll be passing the type. And once I've passed the type, clearly we can see this is series and this is the data. This is the data for which we have obtained this series, right? So this is my data. Then if we further observe over here, now I want to, let's say, display a single column as a data frame. So which column should we go with? This time I'm going with city. Over here I'll be writing df city, and in the df city, because I want to read it as a data frame, so I'll be passing double square bracket. Alright, or maybe a list, a comma separated list of columns that I wish to display for reading more than one columns at a time. That is our requirement. So reading a single column as a data frame, over here we have read a single column as a series. Now I'm going to read a single column as a data frame. So if you observe this, what is the scenario? We have Delhi, Noida, Kolkata, Noida, Delhi, Kolkata, and Delhi and Noida. So clearly the output is a data frame. So if the output is a data frame, it would be displayed with alternative rows colored in slight gray and the remaining alternative colored in white. So this looks like a much proper tabular structure compared to this, the series, right? So let's check the data type. So clearly if you observe, the data type is data frame. So this is how a single column can be read as a series, a single column can be read as a data frame as well. Now, can we read only single column, or do we have the option of reading multiple columns? We do have the option of reading multiple columns as well. Let's see how. So if we were to suppose, if you're supposed to read multiple columns, so maybe I'm fetching name and age. So this is multiple columns. So this is always going to be a data frame. If I'm fetching multiple columns, it's bound to be a data frame. All right, it cannot be series because we have discussed this property, right? When we are talking about a series can't consist of more than one column. So it is bound to be a data frame. We were over here, I guess. Yes. Now I'm writing this over here and then type of this, and then maybe I can copy this part over here and I'll display this. So if you observe this, this is going to be a data frame. This is going to be a data frame, pandas.core.frame.data frame. All right, so over here I'm having name and age. So this is how we can we have read multiple columns. Next, moving forward, after having read, let's say, name and age, then maybe we can proceed to, let's understand a very important question, how to add a new column to the data frame. Now there are two options, means there are in fact multiple options, but I'll tell you the very basic one. So if I'm supposed to add a new column to the data frame, there are a couple of things that we should be mindful about. The number of rows must match the number of rows in the data frame that you already have. The number of rows in the column that you're supposed to add should match the number of rows that we already have in this data frame. So we have a total of 8 rows. So let's add another column. Let's call this department. So the way we add new, let's say, key value pair in dictionary, it is the same procedure that we are supposed to use over here. For instance, if I'm having a dictionary A110 and A220 and I'm printing D, so if I were to add a new key value pair, all right, so maybe C A3, over here I'm writing A3 as 30, then I'm printing D. So what is the output? Over here my output is A1 is 10, A2 is 20 and A3 is 30. All right guys, this is what we have. Now let's understand how to add a new department, how to add a new column. So the way we have added a new key value pair in the dictionary is the same procedure that we'll be using to add a new column to the data frame. So let's consider the department as maybe sales, admin, all right, HR, then IT, maybe sales. So this is 7 and then maybe admin, all right, and I write DF. So observe this. If you observe this, this is the data, right? Now I've added as many rows as were present in the original data frame, so this column is added. If you add a column by in using this approach, so column will be, let's say, added at the end. All right, this would be the last column that has been added. It will always be added in the last. So now what is the shape? So the shape has changed, right? Now we have, previously it was 8 3, now we have 8 4, indicating what is the number of rows. The number of rows is 8 and the number of columns that we have over here is 4. All right, so guys, this is how we are supposed to let's say add a new column. Now considering the different data frame operations, the first operation that we are going to look at is renaming columns. So if we were to rename the columns, now these operations we can also perform in SQL, but let's understand how to rename the columns. So what all columns do we have? These are the columns, right? Now there are two options. Either we can rename all columns or we can rename specific columns. Let's consider both the scenarios. So suppose instead of maybe city, I want to call city as location. So how do I change this? I have to write df.rename and then I have to mention columns, and in the columns city was the old column name. I wish to change it to location. This is how I can write. And maybe department, or let's say instead of name I want full name. Instead of name I want, or let's call this employee name. This is what I'm passing. So it would rename the table. Currently if I run this, see, the table structure is changed, but is it changing the original table or is it just applying the changes to the copy? Currently it is applying the changes only to the copy. The original table structure is not changed. So if you want to make the changes permanent, or if you want to ensure that these changes do get applied on the original data frame, so we have to write a command called in place. In place is equal to true. In place true indicates, all right, changes would be implemented in place. In place means will impact original, will impact the source, all right, and otherwise it won't. So as you can see, the column names have been changed after writing in place. Now if I show the data frame columns, see, the column names have been changed, and if I show df, clearly we can see the column names have changed, right? Employee name, age, location and department. Now we do have the option to rename all the columns, so I can simply rename them like this. Maybe over here I'm writing e name as in the employee name, so age will be age, instead of location I'm passing region, and department would be department. So guys, if you observe over here, df, all the column names have been changed, right? The column names have been changed. Next, we do have a couple of additional functions that we can work with in pandas. So let's explore a couple of these functions. So the first function is unique. Unique simply returns all the unique values from a column. So how do we use them? Over here I can write df, maybe I want to see what all different cities do we have. So unique dot unique. So this is the alternative of utilizing, let's say, the distinct keyword that we have in SQL. So dfct.unique. So what are different? Okay, now I think it's not city, it is region, right? So what all different regions do we have? We have Delhi, Noida, and Kolkata. All right. So this is how we can utilize the unique. Likewise, we have, let's say, uh, n unique. What does n unique represents? N unique would represent number of unique values. So unique is, let's say, total unique values, and unique is count of all the unique values, right? So this is count of all the unique values. So if we check the count, what is the total count of all the unique values that we have? The total count of all the unique values is 3. All right. So guys, this is how we can apply this, and this was for region. I can also check it for department, right? So even department has different unique departments. So let's check the unique and the n unique. N unique is simply the number of unique values in that column. So department column, clearly we can see that there are 4 different departments. We have sales, admin, HR, and IT. And what is n unique returning? N unique is returning 4, indicating that there are 4 unique values. So this was for region, and this was for the department. All right. So guys, in this session we have discussed, let's say, all about series and data frame. All right. We have introduced a library called pandas, and then we have discussed series and data frame, how to create series, how to create data frame, the different methods of creating data frame. Then we have seen an example of data frames from the scratch, and we have understood the different data frame properties such as shape, dtypes, columns, index, and values. All right, then we have seen different data frame functions such as head, tail, and sample. Moving on, then we have discussed, let's say, reading single column as series, reading single column as data frame, reading multiple columns, and how to add a new column to the data frame, right? And then we have also seen renaming the columns, and couple of additional functions to, let's say, help us out in the times of need. We have unique and unique. So guys, that brings us to the end of this session. So I'm switching to the PPT. So guys, as far as this session is concerned, we have understood series and data frame. We have worked on series and data frame properties. We have also discussed different data frame functions and operations. So in the next session, we'll be discussing about how to read a CSV or Excel file, and how to save a file, let's say save a data frame as Excel and CSV. Thank you.